Okay, it's 9:45. Guess we'll go ahead and get started. My name's Andy Rivenes. I'm a product manager for database and memory with Oracle. So I wanted to talk about new features in database and memory. And then I have the INSYNC slide and then kind of my Oracle slide I use. Notice my email address is there and Twitter handle if you want to follow me. I do tweet and we do blog about new things in database and memory. So if you want to follow our blog for any new information, we also have on the blog, I'll show you at the end, a resources page where we do Ask Tom office hours sessions. We have a resources page where you can get YouTube channel videos, a lot of articles and white or technical briefs about different parts of how database and memory works. So we try to put in a lot of information out there for you. So if you want to take advantage of that, I kind of point people to the blog being kind of our portal into all things database and memory, as you will. So with that, we'll go ahead and get started. So first off, I'll just give you a little brief introduction to database and memory if you're not completely familiar with how it works and what its purpose is, and then we'll dive right into the new 21C features that are available with database and memory. So we call it database and memory. It's an option to Oracle Database. It is available in the cloud on the EXA platforms plus Extreme Performance, and then on premises as part of Enterprise Edition. It is an option, and people kind of hear in memory and they think database and memory is going to speed up everything. And so really it's focused on analytics, kind of asking those what-if type questions, whether you have existing reporting or perhaps would like to be able to do some reporting on your data in real time as opposed to having to wait till that data gets transferred to maybe a decision support system or your data warehouse. And so that's kind of what this is about. And so I kind of want to make clear the purpose for database and memory, and that really is improving existing reporting performance. I usually tell folks that if you're not getting at least a 10x performance improvement for your analytic workload with database and memory, then I'm personally disappointed. We typically have customers who are getting at least an order of magnitude or better performance improvement. And so anywhere you have existing reporting, talk just briefly about the fact that since database and memory is fully integrated in Oracle Database, you don't have to change your application code to take advantage of it. And so you can enable database and memory on your existing applications and hence the existing reporting environments. In addition to that, something we call real-time analytics, or the ability to actually run analytic reporting right on your, what I call source workload or source data, as opposed to waiting for that data to be moved somewhere else before reporting or analytics can be run on it. This is a real game changer, the ability to run analytics in real time. And just want to make sure I got that question. Excuse me. So in real time, so ad hoc type queries, drill down type queries, or even just the ability to run or ask questions of your data without having to wait for it to be transferred maybe to your data warehouse system. So we think that's a real game changer. We have some YouTube videos, one we did with the real world performance team you could take a look at that help point out that since it's just CPU and memory, as long as you have CPU capacity in your source systems, you can run database and memory and not degrade your OLTP environment. So what we call mixed workload, where you're running OLTP and would like to run reporting, or perhaps in this case, database and memory analytic workload. And then another big benefit is typically you've had to create a lot of analytic reporting indexes on your row-based data in order to get that, in order to be able to run reports in a reasonable fashion. And so since database and memory doesn't use analytic reporting indexes, now we're not talking about OLTP type indexes where you might have constraints, primary key, foreign key constraints, where you might have lookup type indexes where you're just getting a few rows. But for those indexes you had to add to do reporting, typically you can eliminate those indexes with database and memory, and that can free up a considerable amount of workload and capacity on your OLTP system and workload, because now you're not having to maintain those indexes, you're not having to generate, undo, and redo, you're not having to have the disk space allocated for persistence or backing up those indexes. And so that can free up a considerable amount of workload, which then can be replaced with real-time analytics. And in general, those real-time analytics are much less costly than I/O-based analytics are, because now we're just using CPU and memory. So I kind of wanted to make sure that everyone understood the purpose and the use case for database and memory, which is analytics. And then I'll describe just briefly here what it is and how does it work. So Oracle's traditionally been a row-based database. Rows are great for online transaction processing. Columnar formatted databases have been around for a very long time. They're great for running analytics on, because you only have to look at the columns that are part of the query. Those columns tend to compress well. You can do vector processing on those columns. Works very well for reporting. Doesn't work very good for OLTP, simply because now you have to stitch all of those column values back together to associate them in essentially a row format. And then in the row format, running reports tends to be very costly, because we have to look at a lot of data. You have to get each row, traverse that row to get to the columns you're interested in, or perhaps index those columns. I mentioned analytic reporting indexes, and you have to know the questions you're going to ask in order to have the proper indexes set up. So the two formats are kind of have specific use cases for them. And the great thing about database and memory is that we combine those two formats into Oracle database. It's the same Oracle database that you run for all of your current processing. We introduced database and memory in 12.102. Have improved it in 12.2, 18C, now 19C, and then 21C, which is now just coming out. And so we continue to enhance the product. But what the bottom line is that since it runs as part of Oracle database, you don't have to install anything separate. The cost-based optimizer determines, am I going to access my data from the row store? Maybe I only need to look for one or two rows. Maybe I'm just doing a primary key type lookup, accessing and operating on a transaction in one or more related rows. Or maybe I'm doing analytics and I want to access the column store in columnar format. And so that's a cost-based decision, which means you don't have to change your application. So Oracle supports EBS. It supports PeopleSoft for analytic type queries, JD Edwards, SAP. We have several use cases and stories out on Oracle.com. SAP customers can take advantage of database and memory. Anywhere you're running Oracle database, basically you can run database and memory if you have analytic workload. And then that's kind of the other takeaway from this, is that since it's part of Oracle database, any changes to data are reflected in both the row store and the column store. We preserved Oracle's transaction architecture. The advantage, of course, with InMemory is that since there's no persistence, it's truly in memory. We don't generate any undo or redo. We don't have to have backups of the data in columnar format. We repopulate as the instance restarts. That's the in-memory part. And all of your applications can run unchanged. And so that's kind of the really breakthrough with database and memory, is this ability to have either row formats for OLTP or columnar format for reporting and analytics. And the cost-based optimizer takes care of deciding which format you access. Very easy to set up. Set in-memory underscore size, which is an init.org parameter for DBA folks. You allocate memory out of the SGA for the column store. You alter the table, partition, subpartition, or materialized view to be in memory. That gets populated in the background in the columnar format. Perhaps later you can drop your analytic reporting indexes, and away you go. So it's very, very simple to take advantage of. We do have quite a few Ask Tom office hour sessions, which are videos that you can look at, plus our YouTube channel. If you want to find out more information about how database in-memory works, I'm not going to go further into the workings of it because I do want to get to our new features. But there's a lot of information available, plus you have the blog and our resources page, which you can take a look at. And then we have our own documentation, our in-memory guide, that you can go look at how database in-memory works, how to set it up, how to maintain it, what you can do with database in-memory, why it can provide orders of magnitude better performance. And so with that, let's talk about what's new. So the takeaway here is that we're talking about analytics. So I was thinking we could have a test, but I don't really like tests. But the question would be, what is the purpose of database in-memory? To speed up everything, one size fits all, or to speed up analytics? And so analytics is the correct answer. So hopefully you could take that away, and let's see what's new in database in-memory. As I mentioned, database in-memory came out in 12.102, so 12.1. We've added significant features in 12.2, as you can see, 18C, 19C, and now 21C. And so what we're going to focus on for the rest of our today's session is these enhancements and new features that are available in 21C. 21C is available in the cloud currently, and so it's soon to come out in all flavors of Oracle database. So this is kind of a great opportunity to see where database in-memory is headed with 21C. So new features. So we'll start with the first one, which is in-memory vector joins. So it's actually part of an in-memory vectorization framework. So database in-memory makes heavy use of SIMD vector instructions, a single instruction, multiple data. I'll show you a little bit of an example of join processing, both with Oracle row-based join processing and hash joins. But the bottom line here is that in-memory vector joins is the first feature to leverage our in-memory vectorization framework. And what it's doing is it's significantly speeding up hash join performance even faster than our existing optimizations that we've added as part of database in-memory. And so what we're basically doing is allowing you to do, or allowing the hash join to do multiple comparisons rather than looking up in a probe table. We use Bloom filters, but being able to do this with SIMD vector processing to be able to do multiple or array processing on the join criteria as opposed to one query, or one equality predicate at a time. So rather than me trying to fumble through that explanation, let's look at a couple of slides that show us exactly what I'm talking about. So traditionally in a row store join, hash join, and I'm not going to go through this in too much detail, we have a lot to cover today, but we do have an Ask Tom session where we present all this. Maria and I have done a session where Maria Colgan and myself, we go through all of the details, but suffice it to say that a hash join between two tables, typically one smaller than the other, in the row store, we scan the smaller table, apply any filter predicates, and we'll build a hash table in the PGA, which we'll then use to scan when we scan the second table, and we'll probe that hash table to find any joins that are in quality rows that match based on the join key, and return that then from the hash join. That's very efficient, but we actually have to do a probe in the PGA to find join matches, whereas in database in-memory, we do basically the same concept, but now as we're scanning that columnar formatted data, which we scan much faster, we build a Bloom filter based on the join key and on the smaller table, and then we apply that Bloom filter as a filter predicate when we scan the larger table, or in this case, the sales table. And so we basically can avoid having to probe the hash table in the PGA because we can just treat the actual join criteria as another filter predicate when we scan the table. Very often I'll tell folks The fastest database in memory query is one where we can do all of the work as we scan each of the tables as part of the query. And this is one of those benefits or enhanced features that comes as part of database in memory. Now, since a Bloom filter is a probabilistic structure, it can have false positives, so we will go back and check our matches in the hash table and pick up any projection columns as we return that data or those results back to the calling query. But typically we get a 10x performance improvement over a standard hash join with a database in memory join where we can create a Bloom filter from the in this case storage table and apply that against the sales table. So now we get to in-memory vector joins. Kind of wanted to get you the background of how we operate with a hash join, and then with in-memory vector joins, that Bloom filter processing where we're comparing for the join on the join key between the two tables. In this case, we have our Bloom filter and our sales table. We're actually able to use SIMD vector processing to do that. So you can see my little picture there that we're actually able now to do this with multiple values using the SIMD vector processing. And so this speeds up that actual join comparison by almost an order of magnitude. So now we get close to a 15x performance improvement as opposed to 10x in without this enhancement. So that's kind of what we're headed with a lot of these features in 21C with database and memory, is to improve performance even further. So we're planning on introducing more features that leverage this vector processing ability, and this is just the first one. In-memory vector joins are enabled in the database, and we automatically, but we do have a new init.org parameter, in-memory deep vectorization. By default, it's true. It's possible to set it to false. Pretty much the only reason to do that would be if you were going to do testing to see how much benefit you might get. Bottom line is just it automatically is enabled. Once you enable the in-memory underscore size parameter, set up the column store, populate your tables, you don't really have to worry about it. But sometimes the devil's in the details, and you like to know what's going on under the covers, so you can enable it or disable it. And then in addition to that, to tell if you used or leveraged in-memory vector joins, you can look at a SQL Monitor active report. So in the hash join section, line or execution line, if you look at the binoculars and click on those, you can actually see whether those deep vec hash joins won. So that means we leveraged a in-memory vector join for this particular query. Now, this is similar to what we do with join groups, which is another feature that we added in 12.2, where you use SQL Monitor active report to determine whether you used the feature. Part of this is because we use this feature at execution times, so the optimizer isn't deciding whether or not it can leverage the in-memory vector join. It's still just a hash join. We're doing that as we do the scan as part of database in memory. So if you're confused or if you're not familiar with SQL Monitor active reports, real-time SQL monitoring, it's a feature of Oracle Database. It's been there for a long time. You can look it up in the documentation. I also have a brief, that basically a cheat sheet, if you will, that shows you how to access a SQL Monitor active report, either by creating it yourself when you run your SQL statement or accessing it through the Enterprise Manager screens that might be available if you're using Enterprise Manager, either Cloud Control or the single, I always forget the name of it, the singleton version of Enterprise Manager with your database. So there are a couple of ways to access or create a SQL Monitor report, and then once you get to that point, you can then look at that and see. There's lots of other things you can do with SQL Monitor reports, but that's one of them. You can validate whether you were able to leverage in-memory vector joins. The next feature that we've added to database and memory is automatic in-memory. Now, we actually introduced automatic in-memory in 18C. We had a low and a medium version. Now we have what we call a high version. So there's a parameter in-memory automatic level that if you set that to high, excuse me, that will enable automatic in-memory. And what the difference now is that we will actually set all of your objects to be eligible for in-memory, and then based on usage statistics, we'll automatically populate or remove the most active, analytic active segments into the column store, and we possibly will even compress the columns to a higher level if rather than removing those columns. So the idea is we're trying to make the column store self-managing, so you don't have to decide either by running the in-memory advisor or maybe understanding your analytic workload. Maybe you have some key reports and you know the tables that are associated with those. But rather than having to figure that out on your own, the database can take care of that for you. And so that's what automatic in-memory is, kind of the next evolution into making it automatic or truly self-managing, I guess is a better way to put that. And when you do this, you set in-memory automatic level to high, either with an alter session or restart the database. What happens is, notice in my screen here that the in-memory compression level gets set to a new value, auto. So we supported both compression, so no compression, DML, query low and query high, capacity low and capacity high. Now we're supporting an auto feature, which is how you know that we're going to automatically not only populate the data, but compress it to the proper level based on usage and workload. And so what we'll do is we'll change all of your objects, anything that's not system related, to be in-memory eligible. Now, it is possible, so it wouldn't be Oracle if you didn't have choices, it is possible to alter a table to be no in-memory so that it avoids the, it's no longer eligible to be managed by AIM. Or you can set any object, if you alter the table to be in-memory, maybe set a specific priority or a specific compression level that you want it to have, then it will also be ignored with AIM. And so you can actually avoid AIM processing view for some objects and then enable it for the other objects if you so choose, maybe based on SLAs or workload where you know you need to always have certain objects, even though they may not get used constantly when they are accessed, you want those to be in memory no matter what. And so we give you the ability to manage that. But in general, if you just set in-memory automatic level to high, we'll take care of managing the column store objects for you and give you the best performance possible from your analytic workload without you having to maintain that. Pretty exciting, I think. I just have an example here of which you can see. You can try this with 21C, is that with in-memory automatic level off, we might have an object that's disabled for in-memory. And in this example, I have one where I've enabled an object for query low. I have an object, UTAB 2, that's not enabled for database in memory. And then I have a third table, UTAB 3, that I've disabled. I don't want it to be in memory ever, for whatever reason. And then we can enable in-memory or AIM to level high. And notice that my first table, since I've set it to be in memory at query low, I've made an explicit in-memory command, DDL change, and then it's not touched by AIM. The second table, which I did not have enabled for in-memory, is now automatically enabled with our in-memory compression of auto. So it's going to be managed by database or by database memory based on usage. And then our third table is again not touched because I've explicitly set it to be no in memory. So that's my purpose of this, is trying to just show you that you can control objects, but that by default, if you don't do anything with your objects, we'll enable those for in memory and let AIM manage that. And then the last example was by setting it to off. Notice that our third table is still disabled. Our second table now is disabled because we go back to what it was before, and our UTAB 1 table is still enabled with query low. So gives you the ability to manage objects yourself if you wish, or let the database take care of it for you. we have an in-memory DBA in-memory AIM tasks and AIM task details, and I just kind of showing you the last one that I had in my test system, just to show that you can see that, oh, so some objects were evicted, some objects were populated. That partial population means it didn't all fit, so it won't be fully populated until it becomes more active than currently populated objects. So you don't have to know any of this, but if you want to poke around and see how AIM is working, we've given you that information just like we do with all the other Oracle options and features that are available. We have, $V views and DBA views for all sorts of things, and AIM is also one of those where you can go back and then see what's taken place. So that's AIM. In-memory hybrid scans, another great feature, one that's has been asked for traditionally in Oracle database and memory up to through 19C. If you populate an object and exclude columns, because perhaps there are columns that get used very infrequently, and you're trying to save space in the column store, if you then run a query that accesses those columns that have been excluded, the entire query has to run from the row store. Now, with 21C and in-memory hybrid scans, we changed that. If, excuse me, you've excluded columns and you do query on them and they're in the select list or projection columns, then we can still run the query from the column store, and then we'll just go pick up based on the column values of the rows that have been returned from that query. Those columns that you've excluded, we'll get those from the row store. So you might ask, well, what's the big deal with that? Well, the difference is that now we can give you in-memory performance and pick up just those columns as opposed to having to run that query entirely from the row store. So even though it won't be as fast as if the data was fully populated in the column store, it will still be typically much faster than if you ran the entire query from the row store. You can actually see this, and I have an example here. In my case, I've taken the line order table, which is from our SSP schema, the one we use for a lot of our examples, and I've excluded the extended price. But then I'm going to query the extended price as part of the calculation in my query against the line order table, and in this case, there's a join as well to the date dimension table. So that's my example. And you'll actually see then, if we take advantage of a hybrid scan, notice the table access in-memory full and then hybrid. So we'll tell you, or the optimizer will tell you at parse time, yes, I'm going to run a hybrid query because even though that table or that column value was excluded, I know that it's only in the select list, so I can go get and run the table because the table is populated in the column store. I can run that query through the column store and then just go get my extended order price column from the row store based on the results. And so I can get better performance than if I had to run the query entirely from the row store. So that's in-memory hybrid scan. And if you do have a question, please feel free to type in a question. I'd be more happy to try to answer those questions. Hopefully we won't run out of time. We have about 15 minutes left. But if there's something that you don't understand or are missing, please let me know. Again, all of this is documented in the 21C documentation, which is available. And we've run some Ask Tom office hour sessions to talk about this as well. So maybe we'll go back and see some examples from that as well. In-memory JSON. So we've supported JSON in Oracle database, and we support it in the column store. However, in 21C, we now have a new JSON data type itself. So it's got its own data type. And kind of the takeaway here is that database and memory also supports that data type in the column store. And so so I wanted to show an example. So that's kind of the lead-in. But basically now I have a table that, this actually follows from the JSON developers guide, their examples. J purchase order, we have PO document that's a JSON data type. And I'm going to run a query where I'm going to look for JSON exists, and part of the PO document, I'm going to look through that for a zip code that matches 99236. I populated my JSON purchase order table in the column store. Notice the table access in memory full. And now if you notice in the predicate information, in the in-memory portion, we see that, we're actually going to access or use that JSON exists and access that data from the column store in memory. So we can actually do analytics, and this is true both with JSON prior to 21C. Now we actually use the JSON data type, but we can do analytics on JSON data in the column store with database in memory. And so for folks that are running lots of JSON data that want to search through that data to find particular values, you can use database in memory to make that much faster than without database in memory. In addition to that, we actually have a lot of features in 21C for database and memory. We've enhanced our external table support. We have supported external tables since 18C, but now we've added the support for both partitioned external tables. So now you can have external tables that are partitioned and populate those into the column store. Kind of one of the big benefits of external table support with database and memory is that now you don't have to materialize that data into Oracle database. You don't have to create like a temp table of some kind to populate it in the column store. We'll populate external data that you might have in either the object store or maybe you have it in another format, even a CSV type file. We can actually populate that directly into the column store. And so now we support both partitioned external tables and hybrid partition tables. And a hybrid partition table is one where some of the partitions are external and some of the partitions are internal, part of the database. So basically full flexibility for external table support, whether they're standard, just single external table that you've defined, whether it's partitioned, or whether parts of that table are external and parts are internal. So lots of flexibility. It would be Oracle database if we didn't give you the flexibility to access all of your data no matter what format it's in. My example here is one where I've created the SH schema example with the sales table, and I've actually partitioned it, and notice that I have the first three partitions are set to go are external locations, so I can mine my a file out on the file system and create load that data into three different partitions. And then I have the more current data from 2001 to 2003 as their internal local partitions. And so that's how the table's been created. And then one of the to support external tables, you do have to set query rewrite integrity. So my example, I've set that to stale tolerated, one of the requirements of external table support with database and memory. And then I can run a select statement against that table. And notice for all six partitions, I've got the 98, 99, 2000, which are accessing external data, and then 2001, 2, and 3, which are accessing internal data, or partitions, I guess. And then notice we see a table access hybrid part in memory full. So you're seeing now, so we have in-memory hybrid scans. Now we have in-memory external table support, where we're showing you in the execution plan what we're doing or what we're going to attempt to do. So assuming that it all works properly, you can actually see in the execution plan, the optimizer said, oh, part of those partitions are internal and part of those partitions are external. And then you can see that you actually were able to leverage that since we scanned our 6 partitions. Notice the P start to P stop 1 to 6, so the optimizer thinks it's going to scan all 6 partitions, and it can do a hybrid partitioned query against that data. So that's pretty interesting, I think. So we have two additional features which aren't directed towards kind of traditional relational data. Both in-memory full-text columns and in-memory spatial. I'll talk about both of those. In-memory full-text columns the ability now to access text data without having to have external text indexes created. We can actually create the text indexes within the database. So when you, and so that's kind of what this is kind of showing us, the text index accessing data in a text column. We can do all of this in the column store itself. And simply by altering the table, telling or setting in-memory and identifying the text column, this will automatically create an in-memory text index. You see the sys context mkivvidx column, but that's basically what is getting created under the covers that's going to get populated into the column store. Then when we do our query, and in this case we have to use a contains to trigger the mechanism to access that data in the column store, we can do our contains and description, and then below you see that we did our table access in-memory full, but you see that now that sys context contains is actually accessing, whoops, there we go, the context index that got created as part of identifying that we're going to do an alter table in memory with text, the text word, and then the column, in this case, for the text search that we're going to do. So we call that feature in-memory full-text columns. In addition to that, we're supporting spatial in the column store as well. Same idea. Actually, both these features leverage something we came out with in 12.2 called in-memory in-memory expressions that leverage the ability to, in the in-memory expressions case, create arithmetic expressions and populate those or materialize those into the column store so that we don't have to evaluate those expressions over and over again. And then we're leveraging that for full-text in-memory full-text columns and in-memory spatial. And with in-memory spatial, we now can avoid having to create an external spatial index. We can actually incorporate that into the column store as well. So that can significantly speed up spatial queries that are looking for particular points or areas in the spatial data. And same kind of idea, we do an alter table with, in this case, I have a city points example in memory, and I identify the spatial column, in this case, a shape column. And then under the covers, we're going to create min-max indexing that's going to get populated into the column store along with the data, so that now we can avoid having to actually access an external spatial index. We can do all of this in the column store. And then we see this in our query, similar to the in-memory full-text columns. I'm using an SDO filter command, so I have to use SDO filter, and then I have a geometry where I'm identifying certain points that I want to access. And we see, again, a table access in-memory full. And you see this again in the predicate information, in the filter predicate, that we're accessing those geometry min-max values that got created in the previous slide as part of our identifying this is a in-memory spatial shape or index column. Well, sorry, an in-memory spatial. The shape column is going to be a spatial column that we're populating in the column store, and we're telling database in memory that that's a spatial column. So we want to create these special spatial indexes that we then populate in the column store and then access as part of our query. So again, we're looking at supporting non-traditional relational data in addition to, of course, traditional relational data in the column store to speed up kind of the part of the support for the converged database in database in memory as well. And we're almost out of time, but I do want to be remiss if I didn't talk about the base level feature, which now gives you the ability to try out database in memory on your existing Oracle databases by setting the in-memory force parameter to base level. You can use up to 16 gigabytes of in-memory column store without triggering the database in memory option or the database in memory license. So that's pretty exciting. The idea is to give customers the ability to try out database in memory without having to license it first. And so 16 gigabytes, you might argue, isn't that much space. But with compression, typically at least a 2x compression rate, that's 32 gigs. We support it on rack. Let's see, I have another slide here. We support it across rack and multi-tenant. So now you can actually try out database in memory without having to license it first. Again, the in-memory force parameter, you set it to base level. You can set up to 16 gigabytes of column store. And we even backported this to 19C. So starting with the 19.8 July release update, you can try this in 19C as well. So we backported this to give hopefully folks the chance to see the value with database and memory. And in 21C, you'll be able to see all the features that we just talked about, but all the previous features, but even just seeing the columnar format speed up in kind of on your data. And so that's kind of the idea behind the base level feature. I just had in one example, sometimes I get asked, well, what happens if I try to allocate more than 16 gigabytes? And you'll get an error. So we're going to, with the in-memory force parameter set to base level, will prevent you from over allocating. You won't trigger any licensing issues. And so you can try it free and clear on 19.8 and above. And then there are certain features, just a couple of features. Pretty much everything works with the base level feature. You get the default compression level. You can't exclude columns and you can't use AIM. No cell memory, but basically everything else works. So there's plenty of features, and of course the big feature of being able to do a table access in-memory full with database and memory, and you can really try it out and see kind of the benefits that you might get with your queries on your data. But I did put in the caveat. Where can you get more information? I mentioned this at the beginning, and we're just about out of time. The blogs.oracle.com in-memory is our blog. That's the page on the left side of your screen. On the right side of the screen, our resources page, which I show you how you can get to. I've already uploaded these slides, so you can download these slides. But all of this information is available. We have, like I said, our YouTube channel, our Ask Tom office hours, documentation. We have lots of tech briefs. We try to give you as much information as possible, and my email address is at the beginning of the session. You can always email me if you're stuck, if you have a question that you have a question, and I'll get you the answer to that question. So if we're kind of right at the out of time, if there are any questions, I can stick around. Otherwise, thank you very much for attending.